What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about combinations. So, combinations of items occur when the items are selected from the same group, no item is used more than once, and the order of the item makes no difference. In this case, with combinations, ABC is the same as CAB, right? Because the three letters are all in there. It's just in a different order, which is okay. All right. So these would mean the same thing, where a permutation, these two don't mean the same thing, because in that case, the order does matter. Where this, the order makes no difference, meaning it doesn't matter how it goes, these three things are still there. So in other words, if you were to pick three books, right? You chose them and you put in the basket. It might move around in the basket, but it's still the same three books. All right. So that's what combination is. All right. And here's the formula for combination: is n factorial divided by n minus r factorial times r factorial. All right. So let's talk some examples. All right. So of 11 possible books, you plan to take 3 with you on vacation. How many different collections of 3 books can you take? Well, how many possible books do I have? That's n, so I got 11. How many am I choosing? I'm going to choose 3. So I have 11, choose 3. All right. So that formula is equal to n factorial over 11 minus 3 factorial times 3 factorial. So I got 11 factorial over 9 minus 3 is 8 factorial times 3 factorial. All right. So what is that going to equal to? Let's see. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4. Uh-oh. All right. So I guess I'm going to head back here, right? Because what we know is that the 8 factorial, I should say this, you know what? Let's just do it this way. Times 8 factorial, right? So on the bottom we have 8 factorial times 3 times 2 times 1. And I can just shorten this up a little bit, right? Awesome. So we can see that the 8 factorial will cancel out. So I'm left with 3 times 2 times 1. I could reduce if you want to from here. You can definitely reduce if you want to, or you can just say, you know what, I'm just going to go along with this. And no, you know what, it's probably better to reduce. You know what, let's go and rewrite it, and then we'll reduce it. So 3 goes into 3 once, goes into 9 3 times. 2 goes into 2 once, and to 10 5 times. I don't know why I just wrote 6 down here. That should be a 1, right? So on top, I have 11 times 5 times 3, which is going to give me 165. And there we go. Okay, and there we go. All right. Hope that makes sense. All right, to the next. You volunteer to help drive children at a charity event to the zoo. But you can fit only 7 of the 15 of the students that showed up that are present in your van. How many different groups of 7 children can you drive? So essentially you are going to have, you got 15 children to pick from. You have to choose 7 of them. So essentially I have 15, choose 7. So this is going to be a 15 factorial divided by 15 minus 7 factorial times 7 factorial. So I got 15 factorial over 8 factorial times 7 factorial. Okay, do this really quick. Move this up just a slight bit so I can move this up, so I can move all of this up. There we go. All right, so what do we have? We got 15 times 14 times 13 times 12 times 11 times 10, times 9 times 8 factorial all over, 8 factorial times 7 factorial, right? So the 8 factorial can cancel. So I'm left with the 7 factorial. Let's see here. Let's write that out. So I have 15 times 14 times 13 times 12 times 10 times 9 over 7 times 6 times 5 times 4 times 3 times 2, 1. All right. Oh boy, so many choices, right? Because as you guys can see a lot of different choices you can pick. For example, 2 times 5 is 10. So those cancel out. 3 times 4 equals 12. That cancels out. Let me see. 7 goes into 7 once, but into 14 twice. 3 goes into 6 twice, but goes into 9 3 times. Okay, so what do we have left here? We still have a numerator and denominator. The numerator says 15 times 2 times 13 times 3 over, 2. All right, so that means the 2 can cancel out. So I missed that. So I'm left with 15 times 13 times 3, which is equal to 15 times 13 times 3 is a lot. 96,525. That seems like too many ways, isn't it? All right, there we go. All right, now here is some different ones that is a little more difficult, and we have to kind of know when to use which one, right? So these are pretty straightforward on the first 2 examples, where this one here makes it a little more complicated. It says, how many ways can a committee of 4 men and 5 women be formed from a group of 9 men and 6 women? So in other words, we have to choose 4 men from 9 men. And we have to choose 5 women from 6 women. Right? So with that being said, both of these, right? So we have the men part, which is 9 choose 4, and the women is 6 of them. I have to choose 5 of them, right? And that is exactly it. That's exactly what we have, except because it says and, we're going to multiply these two. So 9 choose 4, which is going to be 9 factorial over 9 minus 4 factorial times 4 factorial times this one here, which is going to be 6 factorial over 6 minus 5 factorial times 5 factorial. All right? So we're going to bring it all the way over here. There we go. So what does that equal to? Oh boy. So we're just going to multiply straight across. Let's do that. This could be shorter. So I got 9 factorial times 6 factorial over 5 factorial times 4 factorial times 1 factorial times 5 factorial. Okay, this is interesting. Keep that over here, nice and tight. All right, so what we have, oh boy, this is gonna be long. So 9 times 8 times 6 times 5 factorial times 6 times 5 factorial. And at the bottom I have the 5 factorial times the 5 factorial times a 4 factorial times a 1 factorial. And 1 factorial is just what? 1. Right? So the reason why I kind of laid it out this way is because you can see that those would go away. Right? In fact, maybe I should just write these as the 4 factorial will be 4 times 3 times 2 times 1, and then times 1 factorial for the 1. Okay? So 3 times 2 would give me 6. 4 goes into 4 once, goes into 8 twice. So what I have left over is what? The bottom's all 1s. The top is going to be 9 times 2 times 6. 9 times 2 times 6 is going to be 108. And there we go. All right, the last one. So how many different 5-letter passwords, so we got 5-letter for the password, can be formed from the letters A, B, C, D, E, F, G, and H? So how many letters do we have? We got 1, 2, 3, 4, 5, 6, 7, 8 letters, right? Okay. So we have a total of 8 letters. Okay. And we got to get a 5-letter password. Awesome. So the 5-letter password is going to tell me that, and here's the biggest part. It says no repetition of the letter is allowed. Okay. So that means once I use one, it's done with, right? So here's my 5 letters. So if you think about this, actually, this is going to be a little further apart here than we think. Okay. So I start off with 8 letters with my first spot. Okay. I have 8 letters to choose from. So from 8, I get to choose one of them, right? Okay, so from there, what happens? Well, for the second letter of the 5-letter password, one of the letters gone. So I only have 7 letters left. So I can choose, from the 7, I can choose one of them. And that letter is gone, so the second letter is gone now. So I get to choose one from the 6 that are left, then 1 out of the 5 that's left, and then 1 out of the 4 that is left. And these all have to be together, so these are all ands, right? The first letter and the second letter and the third letter and the fourth and the fifth gives me the 5-letter password. So I'll have to do 8 factorial over 8 minus 1 factorial times 1 factorial. This would be 7 factorial over 7 minus 1 factorial, 1 factorial. 6 factorial over 6 minus 1 factorial, 1 factorial. Five factorial over 5 minus 1 factorial, 1 factorial. And then 4 factorial over 4 minus 1 factorial, 1 factorial. Oops, forgot the 1 here. I did it a couple times, didn't I? Let me just erase that and that. 1 factorial, 1 factorial. Okay. All right, so I have 8 factorial. Let me just do it this way. Times 7 factorial times 6 factorial, oops, times 5 factorial times 4 factorial on top. The bottom, let's do the math. I have 7 factorial times 1, and 6 times 6 factorial times 1, times 5 factorial times 1, times 4 factorial times 1, times 3 factorial. Okay? And what do you notice? Right? So what I have now is 8 times 7 times 6 times 5 times 4 times 3 factorial over this 3 factorial. So that can cancel as well. So what I need to know is, what does 8 times 7 times 6 times 5 times 4 equals 2? And that's going to be 6,720 possible passwords I can do. All right? And there we go. I hope this answers your question. If you have any questions, let me know. See ya. Bye.